Before we continue with the video, if you like what I'm doing here on this channel, please consider subscribing. It helps the channel a lot. Anyway, let's get back to the video. In this episode, we will be setting up some hit detection, and we will then be making use of that to position it properly to match our sprite animation so that we can, in this case, send some damage event over to the interested characters, in this case that we hit with our attack, and they then get damage applied to them. So we can see in the top left here when we do our attack, a little taken damage number here that's being received over there, based on the events and geometry we're using to determine which characters should be hit. Welcome back. In this episode we are going to be looking a little bit at how you can do things like hitboxes, because now that we have the knowledge from anim, notifies and such from the previous episode, we can start to build upon that. So let's look at how we can get hitboxes, for example, to maybe apply damage or something else. To start off with, we will be taking our light attack sheet here that we imported in like the very first episode, and we're going to be extracting sprites from that. We'll create a grid, and we will make it width 64 and spacing 16 in X. I believe that was correct. Looks like the character is in the middle all the way, so that looks good. So let's extract that. So now we have all of these sprites here. We can create a folder, and we can call it light attack. We'll make sure to mark all the sprites and bring them over there. Now that we have all of them there, we need to create a sprite for this, a total animation flipbook essentially. So we'll create a flipbook. We can call this light attack. That'll be fine. And now that we have that, we can open up our... Actually, let's close this down, open it up here. Let's open up our animation source, and we'll create a new animation sequence. We can call this one light attack. Let's choose the flipbook that we created. So light attack. So now we have an animation source with our light attack in it. So that's a good start. Let's make sure that we save everything so we don't lose anything. So the next part here now is we want to make use of an anim notify. So let's create one and have it. So we'll go to create a blueprint, and we create a ZD notify, and we can just choose a PaperZD anim notify here, and we can call this AM for anim notify or something, and call it light attack. In here we want to overload the function for receive notify, and here we can essentially start having our logic for our hitbox. To start off with this owning instance here, if we type in a valid like so, we have the opportunity here now to determine if this one is valid or not. It will be allowing us to determine if something is supposed to happen in the editor or in the game, essentially. If this is not valid, then we can still have something happen in the editor. To show this, we can get anim render, get sequence render component. That's correct. So this one we can get, and for example get our world position from, world location, like so. And now we could right click and do something like draw debug box. So we can say that when this is in the editor, we want to draw a box that is centered on this location, and we can give it dimensions, and we can give it something like 50, 50, 50. Now if we were to use this anim notify somewhere in our animations, like in our light attack, we go in here, we right click, we add a notify, we add our light attack. We can now play, and we can see that if we scroll out, it's not super clear. Let's, for demonstrations purposes, Let's go to our jump start. Since this one is very short and plays all the time, or actually our jump upward. Well, let's add the anim notify here. So light attack here. So we add it on frame 0. If we play now, we can see that, or hopefully you can see that. Let's do this. We go to over here, we change the line color. We change it to something like maybe bright orange, and compile and save. And now you should hopefully be able to see that we get a box spawning around us. The position that it spawns around is, like we defined here, the world location for the render component. This will be represented by the X here, so that's what it will be centered around. And if we stop this now, we can actually remove this one. We don't need it anymore. We can go back to our light attack, and hopefully we should see it clearly here, that the box appears at a certain frame here, the frame 6. So doing this, we can determine, okay, this is where we will be looking for objects to damage, for example, during an attack. So in this case, when we come to frame 6 here, it's around our whole character. And that's a good starting point just for prototyping or demonstrating that the functionality works. So what we can do now is essentially, we want to say that when we're playing the game, we want to instead do a collision box, get box overlap actors, for example. This is going to be essentially identical to this one. So we can get the same location and send it in here, and we can have the same box extent, and it would cover the same area as this debug box would do. If we right click on extend here, promote it to a variable, and compile and save, we can see that this variable that we created, this vector, now automatically has the values that we set in, and allows us to easily change this, but also keep it consistent between these two. So we'll just hook it up like so, and it should be making use of that. This one gives us an error because it demands that we have an object type defined. We can drag off from the object type and just make an array. By default, it will choose something here like world static, but we can right click and remove this pin and then compile, and it's perfectly happy with this if this is what we wanted. Now, this works as sort of a filter. If we don't have anything defined here, that means that it will take everything that's fulfilled. And since we're filtering nothing, that means it will take everything. So if we were now to go to, let's create a character that's going to be a AI stand-in sort of thing. And we open up our folder here where we have our character currently, and let's create a copy. Let's duplicate it and call it BP AI stand-in. No, substitute is better. So this will represent our AI character, just for the purposes of detecting hits from our hitboxes that we create. So we drag this into the world, and we can make sure that it has the 0 value on Y, so it's in line over here. And if we press play, we can see that our character is over here now, or the AI character, AI substitute. So that's fine. Let's check to see if this works. So if we were to overlap on an actor, we want to say which actor did we overlap. So what we can do here is we can make a for loop, there we go. And we can, from that, print, and we can say, actually we won't say anything. We'll just drag out from the element that we have, which should give us the actor that we are overlapping with when this happens. And then we can also have a print string over here just to denote that no more objects, no actors found. So if we play and we do our light attack, but we currently do not have a key to activate our light attack, so let's do that. Let's actually create a input. We go to project settings, we go to input, we create a action mapping. Let's call this one a light attack. And as a key, let's use, I don't know, maybe the F key or something like that. Like so. We can close down the settings. We can now go into our character. There we go. And we can say that when we get our light attack input, our action event for that, we want to have this animation sequence play now. Since PaperZD's animation blueprint doesn't work exactly like the normal animation blueprint, which you can do something like montages for overriding a certain pose in the end, we will be doing something a little bit more adjusted for this. We'll create a jump node, and we haven't created it yet, so we'll just create the actual place where we will be ending up first by copying how our jump node worked for our jumping and falling off event we had from before. So we'll just say when we press this button and the F key, we will jump to a name. Let's say that we jump to, let's call it just attack. Compile, save. We now need to go to our animation blueprint. We can go either to it directly or through our animation source, because we can click over here to get to the animation blueprint from here as well. You can just click the checkbox to move between them because they are intrinsically linked. So in here, in the animation blueprint, we can now create a new state. So we'll go to our state machine and we'll create a right click and go to jump node. We will rename this to the attack, exactly like we named the jump from our character. You can make sure and copy it from here if you want to make sure that you spell it properly. And from here, let's say we want to go to an attack. So we'll just drag from here, create an animation state, say that this is our light attack or something like that. And we want to transition from this to idle once we're done, let's say, like so. Inside of our light attack, we want to play our animation sequence, which is called light attack. Now that means that when we jump to this node, press attack, we jump to this node here. This will play our light attack, which has the animation notify inside of it. This one that we created, which will generate this box, which has the code in it to say that if we're playing the game, it will get all the actors and it will tell us which of those actors we're currently overlapping with the box that we created, which is going to be identical to the one that we used here to debug with. And then we need to have a transition here back as well. We can for now leave it as false, which means that if we go in and play and press the F key, we're going to be playing the attack and then we're going to be continuing playing the attack because we never make a transition. This is perfectly fine for now because we're just doing this for demonstration purposes. And you can see here up in the left, we get a BP character. This is ourselves. We also get some level streaming proxy, which is going to be our environment that we're currently interacting with. Oh, sorry, no, wrong keys. There we go. So let's first, also we can do this. We can go closer to this character over here and press F, and you can also see that we also hit our BP AI substitute if we're close enough for the box to generate it. Now, let's actually start filtering out some of the things that we don't want to have. So we can go to our light attack here, our animation notify, and we could, if we wanted to, add a pin and choose a pawn. Since these characters are inheriting from pawns, that means that when we're now compile, save and play, we're going to be getting only our own character up here. Unless we move close, then we're going to be getting our AI substitute as well. Since we don't want to hit ourselves, we can make use of these actors to ignore. And we can just drag out from that, and we can make an array here as well. And we need to have a reference to the object that we want to ignore in this case. In this specific instance, we want to ignore the character that is playing the animation itself. So we have this anim instance object reference, and from it, if we drag out and type in get own, we can get owning actor here. This is going to be the reference to the character that's playing the animation. So if we add it here, we will now be ignoring that actor from the overlapped actors over here. So compiling, saving, playing, and pressing the button we can see that no more actors are found. But if we get close enough for AI, we can see that we're still hitting the AI. So now we have a more targeted result of what we want to achieve. Let us clean up the animation a little bit. So if we go to our animation blueprint and our transition state from light attack to idle, we want to transition out of this when we're done with animation. What we could do here is something fairly simple. We can get a player, and the player that we want to get is the PaperZD playback player over here. From this we can get some information about the animation that we are playing. So if we type in get playback progress, you can see over here, we can get the progress of the current animation that it is playing. If we were to say if this progress is greater or equal than maybe something like 0.95, means that the animation has played at least 95% through the animation at this point, and then we can say if that is true we can transition back. So if we do that now, we can see that we play and it ends and we resume into our normal idle afterwards. So now we have everything in place essentially. We can detect an enemy character with our box detection overlap, and we have this animation playing, starting and stopping when we want it to. Now we might want to finesse this a little bit and make it a little bit cleaner, because if we look at our animation source here, our box is fairly large around us and not very accurate, let's say. So if we wanted to have something like, let's say our first swing, which is over here in frame 3. Let's say that's where we wanted to do some detection. We could set our event to correspond to, we want to have our diamond in frame 3 for this to work. And then we can say that we want to have damage detected around this area. What we may want to do is something like, let's say first of all that we want to have the box slightly smaller. Let's for simplicity's, actually let's do this. Let's play. So it's maybe twice as high as we want to. So let's say we assume that we want something that's maybe half of this. 25, 25, 25. We go to our animation source and we play again. That's closer. Maybe we want something that's a little bit more small. Let's say 15, 15, 15 or something. Because the swing is still pretty large here. Okay, so that means that it's much smaller now. You can always tweak this to fit whatever needs you have, but it looks a little bit better. But the problem is that it's still centering around our center here, which is not very accurate for the swing itself. So what we can do is we can go into our sprites and we can go and find our light attack. And since we know that in this case the character is swinging on frame 3 here, we can go to frame 3, which is going to be, this is technically frame 3 because it's indexed from 0, and this one goes from, actually goes from 0 to, so we actually have a swing here as well. Okay, so it's a matter of preference where you want to have it. Let's say we want to have it on 2. So let's open up the second frame here. This is the second frame. Now let's say we want to have that box, but we want to have it somewhere else. We could use, like we can when it comes to 3D objects, create sockets. On the right hand side here you can see we have a socket. And sockets you can do on a sprite per sprite level. So you can have different sprites have the same named socket on different positions if you wanted to, for example. So let's say we wanted to add something like sword attack. That's going to be the name of our socket. Pressing enter creates this little diamond you can see here. If we click on it, we can now position it around. So we could now drag it around and say, well, maybe the center for this sword attack should be somewhere here, let's say. Something like that maybe. And then we save, we go to our animation notify. Instead of using our world location as our position now, we can instead go from our component and say get socket location. And since I copied the name, I can now paste it in here, sword attack. And we'll use this instead as our center for both the debug box and for the overlap over here. And now if we go to our animation source and we play, we can see that the square, the box that we're creating, is much better encapsulating our actual swing here now. Which is really good because it makes it look more detailed and accurate when you're actually playing. So again, we just created a simple socket on the actual sprite frame itself here. And now if we play, we can probably get a much better result. So we play, we hit, nothing is hit. Play over here, nothing is hit. We should be really close now. And there you can see we actually hit the character. So it becomes much better when it comes to having the hitboxes detailing properly where the animation is being done. So it's a very convenient way to do it by using a combination of these overlap geometries and having sockets to determine exactly where you want them to be, essentially. From here, it's just a matter of applying damage if that's what we wanted to do. So if we have our light attack over here, for example, we can go through here and say apply damage, and let's say we send a damage of 10. The number is just arbitrary here now. Anything other than 0 will work fine, and our damaged actor will be the one that we overlap over here. And we can go to our, not our character because that's our own, we want to go to our AI substitute one to make sure we're actually hitting the right character. So this one, and inside of here we can right click and say any damage. So the event any damage will fire and get the information when it is getting a damage application event, which is caused by our light attack over here, this one, the applied damage. So we can print out from this and say, when this happens, we can, let's do an append over here. We can say that we have taken damage, and then we can take the number as the second input over here. And we can change the color to something red maybe, so we can see that it's different. And we can change the duration to maybe 4 seconds or something like that. Now if we play, we can run up to our character, we can attack it, and we can see taken damage 10 over there. So everything is working. So what we have done today is we have set up a light attack animation, which we then have used as a reference for our animation notify. And our anim notify, in this case, we have used a debug geometry item to see how it looks like in the editor, to see where we can have some hit detection being done. And then in game we have an actual overlap of the same geometry. So we take that overlapped actor that is of interest, which we are filtering both on pawn and removing ourselves from. Then we're sending a damage event to all of those, which they are of course receiving here in the event any damage. And our geometry that we use to detect these, we have chosen to create a socket inside of the sprite. So we have a very specific location that will match the swing of our current animation to drive which area we want to hit detect from, which is both being used in the light attack, in the debug, and in the actual world when we play, which we can also see when we're replaying the playback over here. So that's all. I hope this was useful. That's all for now. Keep on learning. Take care. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any suggestions or comments you have down below. Subscribe and share this video if you want to see more like it in the future. That is all for now. Keep on learning. Take care.